So you said number 10, right? Okay, so you're trying to write the product here, and we have so what kind of molecule is this on 10?
Like the whole thing, or
Mm-hmm.
it's acetyl, right?
Yes, because you have this lets you know right there that's an acetyl, plus the 2 ether groups. Boom and boom. Okay. So this is hydrolysis of an acetyl. And we walked through that this morning. So the first thing, these are the bonds that are going to break, right? So do you have ultimately, so it's done in 2 steps. So it will convert to, well, when we take one off at a time, it'll convert to just an ester and then back to the aldehyde. So Claire, you're wondering how to write the what?
Okay, I think I was writing it wrong because I had like the structure written out, but I was gonna add like the CH3, like the ethyl and the methyl group with an OH. Like I was gonna.
Right, so you'll have your aldehyde. Plus you'll have the alcohols, you'll have methanol. And you'll have ethanol separately.
Okay, so it's fine to write that?
Because these are 2 different. If they were the same, then you would just form one alcohol, but both will get an H added onto them.
Okay.
So you'll have 2 different ones there. Yeah, that is different from what we looked at earlier. Number 2, because both of the ether groups that are attached here are both methoxy groups. And so the alcohol that's going to be formed when you break both of these off is identical, and that's why we only had to write 1. But that is not how it is on number 10.
Yeah, but that makes sense.
Yeah.
I'm not even sure how to work 6. I don't know if the.
Okay. What kind of functional group do you have in your reactant on 6?
Alcohol? No.
Yeah.
Yeah.
Where's your alcohol?
On the left side.
Uh-huh. Yeah, you're exactly right. This is an alcohol. And the rest is just carbon-hydrogen bond. So this is the only functional group. So we're going to mildly oxidize an alcohol. So we walked through this on the exam yesterday because I had mild oxidation of an alcohol on the exam. So the way this is, I'll make a note, this is chapter 14. So if we go to chapter 14, this is where we really hit on alcohols and their reactions. So see something that says oxidation reactions. Now I'm seeing oxidation reactions with alcohols. So which one do you think we need? Do we need to look at this example right here? Do we need to look at this example right here? Or do we need to look at this example right here? Look at so what's the difference between these 3 examples?
what's branched off of the carbonyl, or yeah.
So look at look at the titles of these examples. So what's the difference between these three titles?
Like I see it, I just don't know how to explain it.
So they all are talking about alcohols. That's the same.
Yeah, the degrees.
The degrees. So this first one is oxidation of a primary alcohol. The next example is oxidation of a secondary alcohol. The last one's how a tertiary oxidation of a tertiary alcohol goes. So how do we know which one we need? What kind of alcohol do we have?
Is it tertiary?
So let's look and see. Here's the carbon. How do we determine if it's primary, secondary, or tertiary?
Is it the carbons that are bonded to that carbon, or is it just how many
Yep.
carbons are bonded to it?
Nope, the number of carbons bonded to this carbon. So how many other carbons is this carbon bonded to?
3.
I'm gonna see if I can highlight 3. There's 1,
2. Sorry.
there's another one, 2. Good, so this is secondary. This is a secondary alcohol. So let's go back to our examples and see what happens when you have a secondary alcohol and you oxidize it. What does it turn into?
A ketone.
A ketone. So what you're going to do, the carbon that is bonded to the OH group is going to become a carbonyl carbon. The rest of the molecule, this side and this side, the other bonds on that carbon, everything else stays the exact same. The only thing that changes is the bond between the carbon and the oxygen. And we remove a hydrogen. There's a hydrogen bonded to this OH, or O, which is what makes it the OH. There's also a hydrogen bonded to that carbon. On a secondary alcohol, we remove both of these, and 1 electron from here and 1 electron from here is what forms our double bond. You don't have to draw the electrons in, but look, there's a hidden hydrogen here, and then there's a hydrogen right here. So everything else on your molecule, we'll call this, oh shoot. R, and we'll call all of this R prime. That stays the same. You know what, I'm gonna try what, Robin, how do I do split screen again?
Just go, press your little, oh crap, hold on. Just drag over from the left side. And then get the PowerPoint, whatever you want, and then drag it on.
Okay. So here, Maggie, that way you can see the example from the lecture, and then you can try to manipulate yours the same way. Okay, so for every single one of these reactions on the lab, there should be an example we can go back to see exactly what should happen.
I don't know. I haven't, like, I'm looking at it too. I think I did it right, but I'm not sure. That hydrogen that comes off that alcohol that we have to bond on, would it not bond on to the carbon with the more substituents?
That is for when we are adding water, when we're doing a hydration reaction for an alkene.
Oh, okay, so
we just put +8. Like, where did the
Where did the hydrogens go?
Yeah. To that OH.
They go on to the oxidizing agent. So we don't know exactly what this is. O2 is a very common oxidizing agent. NO4, potassium permanganate, is a very common oxidizing agent. That is what's going to be reduced. Okay, so those hydrogens will be picked up by whatever oxidizing agent we have, but you don't have to write that product.
Okay, how I just said whatever, there would be no possible way for that hydrogen to bond with that.
Which hydrogen?
Hold on. Oh, hold on, I'm looking, hold on. I have OH, but I have an H. Oh, I don't have another hydrogen. I only have 3 carbons.
Are you talking about number 6?
Yeah, I got it now. I was when I went and looked at the sample, I was like, it had 2 H's because the secondary alcohol had 2 H's, but my alcohol doesn't have 2 H's.
No, secondary alcohol means the carbons bonded to 2 other carbons.
Yeah.
Yeah, you see, if you zoom in on this carbon, you see 3 bonds, 1, 2, 3. So that means only 1 is missing. So it only has 1 hydrogen bonded to it.
That hydrogen's not there though.
It's understood to be there.
Okay, but the way I don't know if the way I drew it though is like with this OH, this H disappeared and I had a double bond to oxygen right down here.
Yeah.
So
Yep.
this H,
The H's go away. See,
because I have 4 bonds now.
the H's go away. Whoops. See, this will go away.
Yeah.
And this will go away. Going. Okay. So these are going to go away. And the electrons in these bonds are going to, one of them swoop down here and one of them swoop here, and that's going to make a double bond right there.
Yeah.
So
Okay.
that's what looks exactly like this, except for the R groups are pointing down, right to the left and down, not right and left.
Yeah. Okay, I got it.
Maggie, does that clarify, or are you still lost on it?
No, I think I got it. Because I think I was just trying to figure out like where the H go, but you said it just disappeared.
You don't have to worry
I
about
was confused
those.
because I
The
thought,
oxidizing agent, yeah, picks the hydrogens up.
okay, because I was probably overthinking, trying to figure out, okay, where does this go? It's gotta go somewhere.
Gotcha. This is a hard lab.
Oh, very hard.
Oh yeah, I have another question on the lab.
Uh-huh.
I don't know where to begin for number 13.
Mm-hmm.
Because we have like a ketone, an alcohol, and another alcohol, right?
Yep. That's exactly right. So you have a ketone and 2 alcohols. So this, let me see. I'm trying to be fancy. Trying to grab the middle bar. Oh, I guess I have to grab, okay. I'm going to share screen with a different lecture. We're going to go to ketones and aldehydes, Claire. And I want to see if I can find anything where a ketone
You mean a ketone and an alcohol?
ketone and alcohol. So look, here's an example. This is a ketone. This is an alcohol. But this is a ketone with just 1 alcohol. Okay. What does that form? Those form hemiketals. You have 2 alcohols in this case. So if we scroll down one more time, so ketone, and here's the alcohol. So that's after one step, we get either a we get a hemicetal. Well, since our starting material we know is a ketone, we would get a hemiketal. If we reacted again with another alcohol, so this is a second alcohol, and they don't have to be the same. You see how this is ROH and this is R prime OH?
Okay, yeah, that
That
makes sense.
indicates 2 different alcohols actually.
Okay.
And so what you end up forming, we know it would be a ketal, however you say it. And all we're gonna do is we're gonna add first step. You don't have to show the intermediate. So you actually can skip over this step and go straight to this. If you can understand your mind, these groups right here, these ketone groups, these stay the same. These are the same that are right here in the ketal. What changes is this double bond becomes a single bond to one oxygen, and then we add the R group from one alcohol to that. And the carbon forms another bond to oxygen. We add the second alcohol group to that.
Okay. Okay, that makes sense.
What chapter is that out of again?
This is chapter 15, I believe. Right? Yes, aldehydes and ketones. So anytime you have, and I know this lab contains a lot of it. I'm not going to drill you guys on exam 2 on hemiketals, hemicetals, acetals and stuff. I want you to see it just because we're going to probably run into it again somewhere in some of the pathways we covered. And that way you're not blown away by what's happening. You somewhat may recognize it. But this lab probably has more than what the exam will have. Anybody get stuck on 12?
I haven't had time to look at it.
Oh, that can't be good. I'm sure it still works. Okay, it still works.
Okay, on number 8, I just keep looking at it. So with my oxygen, I can't double bond it to like, can I make it an alkene? I don't know. I'm just so, I don't know.
So what do we have here? We have what
I
kind of
think we
functional group is on this?
Amine.
Yes. Is it a primary, secondary, or tertiary?
It's a tertiary.
Yes, it is. We have a tertiary amine. So let's go see what we can find. Chapter 16. So it says amines react with water to form. Do you remember what they form? Look in here, we always get some kind of little plus charge on our amine group. So what do we call that when we have a nitrogen with a plus charge on it? It's right over here.
Ah! Hold on.
I'm putting you on the spot.
I don't know. You can't do that.
Yes, I can.
Oh, is it ammonium?
It's okay to say I don't know. Yes, it's ammonium to form ammonium ions.
You're giving me anxiety.
Oh, stop. I'm sick of that word.
Ah.
Y'all are gonna go watch a scary movie. You give yourselves anxiety. Okay, ammonium ion and anxiety is real. I know it's a real thing, but and what? Okay, hydroxide, OH minus. So you got an amine, you got water. This tells you you're gonna form an ammonium ion and hydroxide. Okay.
Oh, okay. Okay.
So look closely here. Here's my amine. Here's the compound that forms when it reacts with water. Let's see what changes. So I got do what?
Can you do the bottom one with the tertiary carbon? Like the
Oh, yeah. This
Okay.
is a tertiary, right? So I got a nitrogen with 3 ethyl groups. And all that I have over here is a nitrogen with 3 ethyl groups and a hydrogen and a plus charge.
Okay.
So what that tells me is that none of this part of my compound changed. Nothing changed. I just added something. All this is the same. What did we add?
The plus charge,
And
the hydrogen.
yeah. So what do you think you should do?
I'm looking.
To this tertiary amine?
Well, you can't add that hydrogen on because then you'd have too many bonds.
I think you can add it.
I have it all drawn on the same, like it is, like over,
Remember,
Okay.
Robin, nitrogen can have 3 or 4 bonds. When it has 3 bonds, it's neutral. When it has 4 bonds, it's plus charge.
It's like because it has the lone pair.
That's right, Maggie.
So it has. Oh, because if it would have had, okay.
A lone pair.
So I have to add a lone pair. That's okay. And then it's going to be plus my OH, okay.
So what are you going to bond to this nitrogen?
I have to bond something to, hold on.
Another hydrogen.
Is that right?
What did we just look at?
Oh, my head hurts.
What is the difference between these two highlighted structures? This is the reactant.
But okay, so when I bond a hydrogen onto that nitrogen,
Yeah.
NH2, hold on, then I have to already have an H2. 1, 2, 3. Oh, then I would just bond the
NH4.
hydrogen, get rid of the lone pair and bond the hydrogen and have a plus sign.
Look at her.
Yeah. Plus OH.
Yeah.
Right?
Then I have to add my plus sign. Okay. My hands are
And
sweating.
then based off looking at that picture, it's plus OH, right?
Yep.
Say less.
Oh,
Is it OH minus? Do we need to include that or?
That is important. The
Okay.
charge on it is always important. So this is nothing more than an acid base reaction.
oh.
Okay, this is your base, and this is an acid.
I wish you would have put more of the no reactions on here.
I didn't write this lab, or I probably would have.
Oh. Oh. Okay, so for number 9, I don't like, I mean, if anybody else needs help, I just want to like ask, so I like, because it makes it easier for me to write what I have first.
You should do that, yeah.
And I just want to make sure I have an aldehyde plus the alcohol, and that's gonna form the hemiacetal.
Perfect, that is perfect.
Okay.
So remember, we're gonna break this alcohol right here. And this hydrogen goes right there. And then this alcohol is gonna be bonded to that carbon through the oxygen. And the double bond goes away. Not entirely, it becomes a single bond.
Yeah, what do we do with this cyclo?
You draw it as is.
Probe. So it would be, I would get my aldehyde and I would still add the cyclopropane, whatever.
Yeah, so this carbon that's bonded to the double bond, so this right here, it will have this methyl group, and then you've got to bond it, well, the double bond will go away. That will become an alcohol group. But how do you write the rest of this?
That one will go away. That become an OH. Your carbon. Oh, that become an OH. Oh, your carbon will be bonded to, well, when the double bond disappears, you're gonna have your OH on top, and then your carbon would be bonded to an oxygen on the right side.
Okay, and then what?
And then would I still do plus and draw the cycloprope thing? Or no?
Like this?
No, because I'm already adding it, so I can't do that.
This is all one molecule. Let me change my color here. This is all, you don't change, this is all one molecule. You gotta keep it together. We're not breaking any of these bonds. These bonds all have to stay.
Uh-huh. Oh, God. Well, I'm forming a hemiacetal. So.
Okay, Robin, let me let me try to simplify this for you.
Brain hurts.
Pretend that this right here, I'm gonna call this R.
Okay.
So what we have is, here's my alcohol, R, right?
Uh-huh.
And I told you that, well, let me scoot the hydrogen over. I told you that we're gonna break this bond right here. That's always where we break the alcohol.
Mm-hmm.
And what's gonna happen is that this hydrogen, we said, goes to that oxygen. I think you got that part.
Yeah, I got that part down. I'm just confused.
This part of the molecule is gonna be now bonded to that carbon.
Oh, so I just bond that bigger to my oxygen?
Well, it's all one molecule. Oops.
But I'm just confused on how would I draw that triangle?
You just draw it exactly as is.
Oh, and I just put a bond in between it?
Okay, draw it how you think and then share your screen with me.
Okay. I don't know what to do. Okay.
Okay, so does once you put the hydrogen bond onto that O that's already on the carbon, does it become single bond or does it stay double bonded?
It has to become single bonded because oxygen can never have more than 2 bonds.
Okay.
See, and look here. Okay, so this shows you an example. And in
What?
fact, this is the aldehyde that we have, acetaldehyde. This is the aldehyde that we have. It's just that we have H and then O and then CH2 and then triangle. That's the alcohol we have. So you see what happens when you form the hemiacetal? This hydrogen right here goes where? Now it's over here on the product side. Oh, y'all can't see my screen, can
Yeah, I
you?
don't see what you're doing.
Yeah, I was
Why
about to
did someone
say.
not tell me? Over here drawing on my own screen.
I didn't realize I was muted. I said it, but I was muted.
Nobody can see it. Okay, let me try this again. This hydrogen right here, look on the product side. It's right here. Now see that? And the rest of this ethanol
Hey, that's what I drew.
is bonded right here, directly to the carbon. Nothing about it has changed.
I think I did it.
Okay, show me your screen. Let me stop sharing.
How do I do that? How do I share my screen?
All right, now try.
Try what?
Do you see a place where you can share your screen?
No. I don't know how to do that.
At the toolbar, do you have like a toolbar where it says chat and all of that?
Yeah.
Do you see anything that says share screen?
Oh, there it is. What do I don't know what this is going to connect to, so
So you're saying you don't know what we're about to see?
I don't know what it's going to connect to. Oh, I have to open
I think you have to turn your video on because right now I can't see you.
Okay, hold on. It says I have to allow. Oh, crap. How do I do this mess? Oh, I have to unlock my thing. Hey, my iPad's going to die. Okay.
Oh, you got an AirPlay over to your iPad.
Oh, it's not going to let me do it unless I quit the Zoom and reopen it. I'll just show you what I did. Maybe you can see it. I'll get really. Oh, here I have to share my screen. Hopefully my, stuff doesn't.
Yeah, just hold it up.
Okay. Where's that? Where's that? That one.
That's perfect.
Does that look right?
That's perfect.
Okay, so I did it right. I was confused because I had to flip the triangle.
Uh-huh.
Okay,
You constantly have to do that in organic chemistry, turn the molecule 90 degrees or 180 degrees.
okay, good. I gotta
And
go,
don't ever let that bother you.
okay, I gotta go get my iPad charger real quick.
Okay. Anybody else have any other questions?
How much is this lab worth?
15
Or are the
points.
labs worth?
15 points.
We
All
dropped,
labs are 15 points.
the lowest lab, right?
You dropped the lowest lab score.
Okay, this is probably gonna be my lowest lab.
Oh, I have a question again. It's the same one for number 10. Do we
Mhm.
need to like separate the methanol and the ethanol groups? Like, do we need to put like an addition between them, or is it okay if we run them together?
It'll be two separate compounds.
Okay. All right. Thank you.
Mm-hmm.
So we're gonna need 2 additions on that reaction. then.
You'll have 3 products, yeah, on that one.
Yeah, okay.
So do y'all feel like y'all are like literally drowning in this stuff? By the way, Robin, you can continue sharing your screen if you want, or you can stop if you want.
Okay, I'll just see how it goes. Oh, am I sharing my screen?
Yeah.
What do y'all see?
You.
Oh, just me?
Uh-huh.
Oh, how do I stop? Did I stop?
Yeah, I think you're done now.
Oh, okay.
Or no,
It was working
maybe
pretty good though.
I just had it on the speaker versus like the gallery thing, so that's why. No, I was asking, do y'all feel like
Yes.
y'all are getting some of this stuff?
Kind of, but I'm having to
Do
look
you
back.
feel like you're just like totally drowning in it?
I feel like the chapters we talked about today and yesterday, I feel like it's a lot more overwhelming than the previous chapters. But I think that's just because there's like more.
There's like a gnat flying around.
Steps.
Here. I'm listening to you, Claire.
No, you're good.
Yeah.
See, and I think I'm the opposite. Because I don't know. I feel like I'm able to, because I guess because we're talking about one specific, like we're talking about the aldehyde, we're talking about the ketones, whereas before we were talking about everything at the same time.
Well, we covered 3 different things today. We covered carboxylic acids, esters, and amides. Then we covered not only their properties and naming them, but then also their formation and their hydrolysis. I'm about to kill this nut.
But that was also like the same thing for me on the test. like the ones that you said people were getting wrong, I was like, well, those are the only ones I got right.
That's a good, I mean, in some way, that's a good sign that you got those right. Okay. I'm trying to prepare myself for like when we hit biochemistry.
I thought you said you didn't like organic. I think I'm gonna like organic better than bio.
Some people do. I was talking to a girl the other night. She's in pharmacy school now. So she took a lot of like organic biochemistry classes, and she was like, I hated biochemistry. I loved organic. I was like, why? She was like, organic, or she goes, biochemistry was just too much for me. And it can be a lot. It's just, I don't know. I like it better.
Well, hopefully, since you like it better, you'll explain it better and we'll understand.
Maybe. There's just, for me, it just feels like this organic stuff, there's just so many reactions. There's so many.
So there's not a lot of reactions in bio?
There is, but we're not focusing on one particular reaction in biochemistry. We're looking at like overall pathways.
Oh, okay.
But sometimes those pathways can have like, so like, it's like, think about like glucose. When your body breaks down glucose, from start to finish, like first reactant to final product, there's like 10 different steps.
That's why we have a note card.
So that can be overwhelming. And there's going to be times where I do want you to know specific steps in glycolysis for specific reasons that I'll explain. But I'm not going to ask you to memorize every single intermediate and every single molecule of every pathway.
Yeah, that's nice. Nice.
But
okay, oxidation of the aldehyde.
Claire, have you been watching the new like Friends release stuff? The reunion?
Oh, I haven't. I'm a fake fan. I haven't really seen all of Friends.
Oh, you're a fake fan?
Yeah, I just have the sweatshirt.
I love how you say it though. I'm a fake.
I mean, my roommates though, like, they love Friends. One of them has seen like every single episode. And she has like a box of all the seasons.
That's how my cousins are. They like literally have seen every episode probably 100 times. I've seen a lot of them. I don't know if I've seen every single episode, but I just saw they were advertising all the Friends reunion stuff.
It looks good.
Yeah, it does.
Ooh,
I have a
okay.
question.
Oh wait, yeah, you go ahead.
Oh.
Sorry.
Maggie, you go
No, you're
ahead.
okay. For number 4,
Yeah.
I'm looking at the example in our notes. Do I need to put on the right hand side? Do I need to put it in that order? That is like on the paper it says plus CH3 CH2OH. Once I do all that and I get what it's supposed to be, does that C need to be connected to CH3 CH2, or do I have to rearrange that?
Sometimes, Maggie, you literally have to take molecules and flip them over. So like if you're going to bond, I'm just going to come up with a blank note for a second. Share my screen. So you have this ketone, right? And you've got some kind of, I don't know, CH2, CH, I don't know, it may not look exactly what yours is, but right? Something like that, okay? And then we're gonna react it with this alcohol. And your alcohol says CH3, CH2O, OH. There we go. Okay? So if we are going to do, and we said this is a ketone and alcohol, we're going to form a hemicetal. So if I wanted to bond this alcohol, I know where am I gonna break this alcohol apart? What bonds? So I've got a bond there, a bond between the carbon, if I just draw this out. Okay, so which bond am I gonna break so that I can take a portion of this alcohol molecule and bond it to my carbonyl carbon? Where am I gonna break this alcohol?
Between the O and H,
Yep,
or
okay. So now I may have to take this portion of my molecule and I'm gonna move it, but I may have to turn it, you see, to bond it. Does that make sense? So don't ever be weirded out in organic chemistry by turning things or flipping things over. I do like this part of Notability better, Robin.
Yay.
Are y'all reviewer people? Like if you get something off the internet or buy it or whatever, do y'all like to give reviews or nah?
Wait, like looking at reviews or writing a review?
I read reviews.
Because I read reviews. I don't
I
really
read
read
reviews
them.
for sure. If I'm considering like, oh, do I want to buy that or do I want to buy that? I will read all the reviews.
Oh, I'm such a review reader. I have to.
But I don't write reviews.
I'll
Yes,
read them for
same
hours.
here.
I should though. But I'm just like, I don't have the time for this.
Okay, number 6. Okay, we went over it and I think I did it right, but now that I'm looking at it, what I drew is I have a ketone and a alcohol that is oxidized, should be oxidized to an aldehyde, right?
Ketone on you said number 6?
Number 6, yeah, I started with an alcohol.
Uh-huh.
And the way I drew it, I ended up with a ketone, but it should be an aldehyde, right? Because an alcohol oxidized.
It depends if it's primary, secondary, or tertiary.
Oh, that's what we talked about. Okay, got it. Never mind. Ignore that. Ignore that.
So I know somebody who is he's a Google reviewer, and I don't know how he's gained this status, but he's like a level 9. I don't know what that means. Google reviewer. So people will literally send him stuff. So his wife loves like to get ice from Sonic because it's like the small crunchy ice.
Never.
So they sent him this ice machine to review, and his wife was like so happy because you get to like keep it and everything. They'll send like really nice stuff just so that he'll write a review for it. Can you imagine?
I didn't
Get,
know
like,
that was
all-
a thing. That's crazy.
I know he didn't have to pay for it, or like people just send him stuff just because he has like a certain Google review status.
Must be nice.
I know, right?
I'm about to start reviewing
Oh, same.
so I can have a good review status and get free things.
I'm really excited. Tomorrow there's something I'm excited to show y'all in the lecture tomorrow.
I'm excited to get this lab over with. My brain doesn't fry. I think it's time for my midday nap.
You sound like my 2-year-old.
Oh, I have my midday naps. As soon as we get off here, I go take my nap. And it usually lasts till 7 o'clock.
Are you serious? Are you like a night owl? Do you stay up late after that?
No, I just sleep a lot. I have
same.
a lot of sleep.
I don't. That's why I have to do my work like during the day because I cannot stay up and study. Like how people stay up till 1, 2 in the morning. About 10:30, if I'm reading something, my eyes will start to close.
Oh my gosh,
I stay up
same.
till like 1. I stayed up till
Y'all
like
know what I used to do in college? I can't believe I used to do this. I would go to Starbucks at like 10 or 10:30 right before it closed, and I'd order a red eye. Have y'all heard of a red eye?
no.
It's just a black coffee with espresso in it. Like a double or a triple shot of espresso.
That's like you
And-
took an Adderall.
And I
I mean, if it works.
I would drink that and then I would sit down to start my homework. I'm so glad I quit that life.
I don't like
that's-
black coffee. I don't know how.
Oh, I could chug black coffee, no problem. It's just after like 5 p.m. when it comes to homework, I have to stop. I can't do it anymore.
Yeah, I don't drink coffee like that at night anymore. I'll drink decaf, but
Oh, see, I can drink a cup of coffee.
so I always do like a cup of coffee in the morning, and then I do my iced coffee in the afternoon. We make our iced coffee at home.
Sometimes I like to just drink a cup before I go to bed.
My husband can just drink a cup and go right to sleep. It like doesn't affect him. I don't know if that's a good or bad thing.
Let's say if anything, when I drink coffee, I get tired. Like it doesn't help me.
Your
I don't-
tongue. Do you get headaches, Claire, if you like go a day without it?
Oh no, I don't. I rarely drink coffee. I mean, I feel like I drink it a normal amount, but at the same time, I maybe have like 2 cups like a week, which that isn't a lot.
Oh,
Okay.
heck no. If I don't have a cup of coffee by like noon, my head's pounding. Or like some type of caffeine. That's so bad. But like,
Yeah. That's probably bad.
yeah. I don't think coffee has an effect on me. Maybe it kind of, I feel like it does, but I think it's just in my head.
A placebo.
It is the placebo effect. It's probably doing nothing, but I think it works. So it's working.
Mhm.
Oh, I have so many. 1, 2, 3.
Any other questions on this? I got office hour on this tomorrow too.
Okay, I only have 5 left, and I'm probably gonna work on those and ask questions about
Save
it
it,
tomorrow.
save it for tomorrow.
Yeah.
I have a
And this is
question.
oh, but yeah. Do you want to go first?
You go ahead, Claire.
Okay, I was just gonna ask. I was just double checking. This is due tomorrow, right?
Yeah, tomorrow by the end of the day.
Okay, that's what I thought.
Maggie?
Okay, so number 11. Will that one be similar to number 9? Will we have to flip that?
I didn't flip mine.
You didn't flip it?
Uh-uh.
Okay.
All right, so we got an aldehyde here, right?
Mhm.
And we're gonna oxidize it. So you know what I'm gonna do? I'm gonna go look at aldehydes and ketones.
It's got
You know- Do you know what we should form?
a carboxylic acid.
Aldehydes are oxidized to carboxylic acids. Good job, Robin.
I looked at my slide.
What you should do. You just can't take all the slides into the exam. So your product should look like a carboxylic acid. Maggie. Robin, I'm about to grade your homework.
Oh, thank you so much.